Good morning, student. Welcome to the class of mathematics. So today we'll solve a question of triangle where a triangle ABC is given whose sides AB, BC and CA of the triangle are touching a circle which is inscribed inside the triangle, right? And the circle whose center is O and it is touching the circle at three different points P, Q and R. If P is lying on AB, Q is lying on BC and R is lying on AC. Okay. So just do a construction. Just join the center of the circle with A, B and C, the three vertices of the triangle. Now we in this question we need to prove that area of the triangle ABC is equal to half of perimeter of triangle ABC into R which is the radius of the incircle, the inscribed circle, right? Now after doing the construction, that is after connecting the vertices of the triangle to the center of the circle and drawing the perpendicular from center to the three respective sides, we can see all these three sides, all these three radiuses are marked in red, right? And we know that it will be, it since it's touching the three sides of the triangle, so definitely this will be perpendicular to the three sides because the three respective sides of the triangle AB is working, AB, BC and CA is working as a tangent. Okay, this is just like a tangent, and a tangent is always perpendicular to the point of contact, the point of contact to the center. This is the radius, right? Now as we said, PQR are the three point of contact of tangents AB, BC and CA, right, which is as per the question given, right? Now let us see, since this is R and R, because these three are the radiuses of the circle. Now we need to prove that area of the triangle ABC is equal to half of perimeter of triangle ABC into R which is the small r, which is the radius of the inscribed circle, right? We can see here, since we have connected all the three vertices to the center of the circle, so we can say that here OP. So let's come to that point later on. Here we can see OP is equal to OQ is equal to OR equal to small r, which is the radius of the incircle, which I have already told you, right? And since we have connected the three vertices to the center, the triangle ABC can be subdivided into three different, or it is consist of three small triangles, right? That means there will be three subsets of the bigger triangle, right? The three subsets are called the three triangles which will compose the bigger triangle ABC. Now we can see area of triangle ABC consists of the three triangles. What are those three triangles? Let us see. If one of the triangle is AOB, right? Then area of triangle ABC is equal to area of triangle AOB, right? Plus what will be the second triangle on the base BC, right? That is area of triangle BOC, right? This will be the second triangle, and the third triangle will be lying on the base AC, that is triangle AOC, right? So these are the three triangles which we are saying as the subset of the bigger triangle. That means these three triangles when will be added upon, this will, the area of these three triangles, when we will add it, we will get the area of the bigger triangle or the main triangle ABC, right? Now we can see here, what is the area of triangle ABC? Any area of a triangle ABC is half into base into height, right? Height will be perpendicular to the base. So just I am highlighting here one triangle, the first triangle, triangle AOB. Similarly, you can consider for other triangles BOC and AOC, right? In triangle AOB, you can see I am highlighting over here with green shades that triangle AOB is half into base into height. We know the area of a triangle, right? So the area of triangle AOB will be equal to half into AB into OP, right? Similarly, the area of triangle BOC equal to half into BC into OQ, and similarly triangle AOC area, that is equal to half into AC into OR, right? So just write up these values over here. We will be writing it as half into AB into OP, right? Which we discussed, OP. And the second triangle BOC is half of BC into, tell us, into OQ, half 1 by 2 into BC into OQ. Here I am showing all these three areas in different colors so that it will be we will be able to distinguish it very clearly, and we will be able to understand the differences between the three bases and the three heights. Though the three heights are the radius of the common circle and all are equal, which I have highlighted over here. So come to the point now. The area of the triangle BOC is equal to half into BC into OQ, as I already said. And the third triangle highlighting into the black with the black pen, half into AC into OR, right? AC is the base of the triangle and OR is the perpendicular, right? You can see all these three radiuses are touching or are just in a point of contact with the three sides of the circle acting as a tangent, right? The three sides are acting as a tangent to the circle at three different points touching at P, Q and R respectively. Now we know that OP and OQ and OR, all three will be same, being the radius of the incircle, right? Now we know that OP equal to OQ equal to OR as shown over and above here on the top in green color. Just put up the value of OP, OQ and OR into the given equation, right? So what we are left with? We are left with half into AB into R plus half into BC into R plus half into AC into R, right? Now what we will do? Just do one thing. Take 1 by 2 into R as common, right? When we will take half into R as common, now we will just take half into R as common. Then inside the bracket we will be having AB plus BC plus AC, right? And what is AB plus BC plus AC? For triangle ABC, this is the perimeter of triangle ABC, right? So the perimeter of a triangle ABC is always equal to sum of all its sides, right? Which is AB plus BC plus AC. So we can see that AB plus BC plus AC as the perimeter of the triangle. So we can write half into R into half into R into perimeter of triangle ABC, that is perimeter of triangle ABC, that is AB plus BC plus AC, which will be equal to, from where we have initiated, this will be equal to the area of triangle ABC, right here as shown over here. So area of triangle ABC. So this was our requirement, and this we have just initiated to prove it, right? So here just I am just in just giving a I am just encompassing it so that you will be able to understand what we have proved now as per the question, that is half into R into perimeter of triangle ABC is equal to area of triangle ABC, where R is the radius of the incircle, which is in radius of the circle which is inscribed inside the triangle ABC, right? So here we can see in the question that as required it's proved, right? Hence proved, right? Now coming to the question. So the first part of the question is proved, right? Coming to the second part, when the length of AB and BC is given as 5 and 12 respectively, then find the radius of the circle, which is small r, right? So here we just I am marking over here that AB as 5 AB, BC and CA. Just I am marking with red colors over here, red lines. The AB here is writing in black color now. Since AB is 5, so writing just along the side of the triangle ABC nearby the red line, the three red lines. Since AB is equal to 5 centimeter, right? You can see here AB is equal to 5 centimeter. So we can write here AB as 5, right? Now BC is equal to 12 centimeter, writing BC here as 12, right? Now we will calculate the length of AC. How? Let us see. Just apply the Pythagoras theorem. We know that by Pythagoras theorem, if triangle ABC is a right angled at B, then hypotenuse square equal to perpendicular square plus base square. This is the Pythagoras theorem. So here you can see angle B is 90 degree, right? And by Pythagoras theorem, h square equal to p square plus b square. So here h is in triangle ABC. Here h is AC, right? H is AC. So just put up the values over here. H square in place of h, write AC. So AC square equal to P square. Perpendicular is AB. So P square in place of P square, write AB square, that is equal to 5 square, and B square base square, that is equal to 12 square, right? So we will get up the value to calculate it as 5 square is 25 and 12 square is 144. So add up to get 169. If AC square is 169, then AC is the root over of 169, which is equal to 13, right? 13 units. So the length of AC is calculated as 13, right? Now, now we just what we have derived earlier, that is area of triangle ABC is equal to half of perimeter of triangle ABC into R, right? We will use the same formula which we have derived, right? Now coming to the second part of the question, how to get it closed or solved, resolved. We need to calculate the radius of the incircle, small r, right? So just going downward where we have proved it, right? So putting up the values over here, we can see this was the formula. Just going downward, 1 minute. Yes, here half into r into perimeter of triangle ABC, right? What is the perimeter of triangle ABC? That is AB plus BC plus CA. And now we are knowing all the three sides, the measurement of all the three sides, right? So using the above formula, just I am writing over here. For any queries, just write into the comment box. I will get back to you. And don't hesitate to put any query or any question to me, because my ultimate goal is to go just get these concepts clear to you so that you can achieve and achieve better in your life, in your exams, in your goals, right? I'm just taking this initiative to help you in whatever the manner I can, right? Don't hesitate to reach to me, right? So here, just coming using the above formula, half into R into AB plus BC plus CA, that is the perimeter of triangle ABC, and we are knowing this is all is equal to area of triangle ABC, and putting up the values of AB and BC and CA. Just see in the triangle, just going above, AB is 5 and BC is yeah, BC is 12, right? Here encircling it, 5, 12 and 13, right? So putting up the values over here, in place of AB 5, BC 12 and CA is 13. This will be equal to area of triangle ABC, and we know that area of triangle ABC we have already derived it, but just see half into base into height. So if you consider the bigger triangle ABC, what will be the base and what will be the height? Let us see. So just in the LHS, we are having half, and in the RHS also half. So half and half will be cancelled out. So in the LHS, R into 5 plus 12 plus 13, that is 12 plus 5, 17 plus 13, that is 30. So R into, we can write over here, R into 30 is equal to base into height. Base into height of the bigger triangle, right? What is the base? Let us see into the figure. Base is BC, on this perpendicular is AB, that is height, which is equal to 5. So BC is 12 and AB is 5. AB is 5. So writing over the value over here, 5 into, no, this half will not be, already we have cancelled it. Base BC into AB, right? So putting up the values of BC and AB into the RHS, what we will have? We will have these values with us. Just going to the figure, and we can see R can be calculated as, in the LHS leave the small r, and into the RHS BC into AB. What was BC and AB? BC and AB. What were the length? BC is, here you can see 12 and AB is 5. So putting up the value of 12 and 5 in place of BC and AB into the RHS, we have 12 into 5, and this will be divided by 30, which will come from the LHS numerator, and here into the RHS it will come into the denominator. So it will be 60 by 30. So just cancel 30 one time, 30, and 32 times 60. So radius of the inscribed circle, a small r, is equal to 2 by 1, which is equal to 2. So this is our answer, right? And here now we have solved the second part of the question, right? So just I am just encircling over here, right? And subscribe to my channel and like. Thank you so much. Happy learning.